Hello everyone, and welcome back to the Fluctus Channel. Modern militaries rely heavily on mobility. And bridging systems are essential to maintaining that advantage. Natural obstacles like rivers, canals, or destroyed infrastructure can halt armored columns and supply convoys, leaving forces vulnerable. Portable military bridges, such as pontoon or modular systems, allow vehicles and troops to cross quickly, restoring freedom of movement. These systems are designed for rapid deployment under combat conditions, often by engineering units working under fire. By ensuring mobility across difficult terrain, bridging systems safeguard logistics, sustain offensive momentum, and give modern forces a decisive operational edge. At times, a river can become an obstacle on the battlefield, which is why the Marine Corps builds temporary bridges to transport vehicles and equipment across. Bridge erection boats, BEBs, serve as a crucial mobility tool for assembling water bridges. They double as ferries over critical waterways, while also providing thrust and anchorage against powerful currents during bridge construction. The system includes modular, foldable aluminum sections that can be dismantled and carried by trucks. Once placed in the water, these folded bridge parts unfold automatically. BEBs are employed to maneuver and connect improved ribbon bridge IRB bays. Each bay measures 6.9 to 2 meter in length, 8.6 to 3 meter in width, and 1.3 to 0 meter in height when fully opened. Notably, the ramp bay is capable of spanning a bank height of up to 2 meters. A single ramp bay weighs around 6,350 kilograms. With BEBs, operators can push individual IRB bays across waterways to deliver initial equipment and supplies to the opposite bank. Eventually, multiple bays are aligned and connected to form a continuous bridge that can cover water gaps exceeding 100 meters. Once the bays are linked, the bridge functions as a floating roadway, enabling the passage of military vehicles such as tanks over open water. When there aren't enough bays to span an entire river, Marines convert them into rafts. They position a bay at the riverbank and carefully load a tank onto it. The ramp bay is then transported across to the far shore. This method is frequently relied upon by Marines to transfer military vehicles smoothly from one side of the river to the other. To ensure these systems can safely perform the task for which they were designed, the U.S. Army Engineer Research and Development Center, or ERDC, has teamed up with the Army's Program Executive Office, Combat Support and Combat Service Support, specifically Project Manager Bridging, to conduct critical testing on one of the Army's most important tactical bridging systems, the Improved Ribbon Bridge, commonly known as the IRB. For decades, the IRB has been the Army's workhorse for wet gap crossing operations. Made up of modular, floating bridge bays that can be transported on trucks and rapidly deployed into rivers or wide canals, the IRB provides a stable platform for tanks, armored vehicles, and logistical convoys to cross otherwise impassable waterways. Its design emphasizes speed, flexibility, and the ability to support heavy loads under combat conditions. But as U.S. Army ground combat vehicles evolve, such as the Moen Abrams main battle tank, the Joint Light Tactical Vehicle, and future heavy platforms, the weight requirements placed on bridging systems continue to rise. Meeting these higher military load classifications is essential to ensure armored brigades can maneuver freely, without bottlenecks at natural obstacles. During recent tests, ERDC engineers, in partnership with PM Bridging, subjected the IRB to the latest vehicle weight limits, measuring not only its capacity, but also its performance under stress. Sensors and strain gauges were installed along the bridge spans to capture how the structure flexed, absorbed shock, and distributed forces as tracked and wheeled vehicles rolled across. These evaluations are key to verifying the IRB's reliability in real-world conditions and to identifying areas for potential design improvement. Beyond simply testing maximum capacity, the program also focuses on long-term durability. Army engineers want to know how repeated crossings, varied current speeds, and different terrain conditions impact the bridge's structural integrity. These insights inform training, deployment strategies, and the development of next-generation bridging systems. By ensuring the improved ribbon bridge can handle the heaviest military vehicles, the U.S. Army preserves its ability to project power and sustain mobility on the battlefield. The work carried out by ERDC and PM Bridging underscores the vital role of engineering innovation in modern warfare, keeping soldiers and equipment moving no matter the obstacle. While the U.S. Army isn't known for its movement of troops on the water, there is a special branch of the armed forces that is. The United States Navy is considered by most to be the largest and most powerful navy in the world. U.S. Navy unit is one of only a handful of military units worldwide that operate hovercraft. Landing Craft Air Cushion, or LCACs, are deployed to transport troops and equipment from ship to shore. Officially cleared for production in 1987, LCACs are deployed primarily from amphibious well-deck ships. These vessels not only operate them, but also serve as transport platforms for the LCAC.
Lowering it 10 degrees to the stop. You're lowering it to 90 and a little bit lower. Got it.
All station control, green well, green well.
Normally manned by a crew of 5, a landing craft air cushion is capable of carrying around 60 tons of equipment and personnel at speeds exceeding 40 knots. These craft play a vital role in moving heavy vehicles, including tanks, from sea to shore. In addition, according to the U.S. Navy, they also provide excellent evacuation support, lane breaching, mine countermeasure operations, and marine and special welfare equipment delivery. Another key vehicle for many Marines, the Assault Amphibious Vehicle, or AAV, serves as the primary amphibious transport of the U.S. Marine Corps. It is most often employed by the Amphibious Assault Battalion to deploy surface assault forces and equipment. Built by BAE Systems, these fully tracked amphibious landing vehicles were first introduced in 1984.
4, 3, 2, 1, launch.
Today, they are well known for their rugged durability and superior mobility in transporting troops and cargo from ships to shore, as described by before anyone else. The company's trademark Big Foot Tracks enhance this mobility, enabling the AAV to handle a variety of terrains at speeds of up to 45 miles per hour. This includes navigating surfs of roughly 10 feet, both toward the beach and back out to sea. In 2020, Marines from the 3rd Assault Amphibian Battalion, 3rd Marine Division, maintained an AAV during a routine training exercise. On that occasion, they removed the vehicle's transmission for repairs at Hokudayan Training Area in Hokkaido, Japan, as part of Northern Viper. The purpose of Northern Viper is to strengthen cooperation with Japanese allies in a bilateral combined arms and live fire exercise. Specifically, it is intended to evaluate how effectively the U.S. military and Japanese forces can operate together. First launched in 2017, the exercise has since become an annual event. Under certain battlefield situations, there is no support available to cross water obstacles. Under these situations, most military vehicles are capable of fording rivers and streams as long as the depth is not too deep. Such deep water crossings not only demonstrate the capability of the machines, but also challenge the skills of the driver maneuvering them. This is vital, not only for carrying out direct combat missions, but also for ensuring the secure movement of supplies and troops where bridges are damaged or entirely absent. Fording is a standard practice in both military exercises and real operations, providing mobility and the element of surprise during missions. This capability proves essential in areas where water bodies either surround or divide key operational zones, posing an obstacle yet offering a tactical edge when executed effectively.
Go ahead and go!
Before these armored giants face the challenges of a deep water crossing, careful preparations are required to guarantee vehicle integrity and mission success. Every component, from oil fill caps and dipsticks to the transmission dipstick and seal, is inspected. The transmission dipstick and seal must be secured tightly. Otherwise, operational reliability cannot be assured. Batteries are examined to confirm that caps are in place, connections are firm, and terminal bolts are properly tightened. Fuel caps are sealed securely. Doors are detached, and windows are left open to reduce potential risks during the crossing. Before the mission begins, water depth is measured to confirm it does not exceed 60 inches, a vital safety limit for most tactical vehicles. Once all steps are complete, the vehicle is ready for fording. The forward vent switch is set to deep fording, and non-essential systems, such as heaters and lights, are turned off to conserve power and lower the risk of electrical malfunction. As the vehicle moves into deeper water, these measures allow for a controlled and efficient crossing. Immediately after leaving the water, procedures are carried out to drain any remaining moisture from the vehicle. Essential post-operation inspections include checking all oil levels for any signs of water intrusion or discoloration to maintain vehicles in peak condition for upcoming missions.
Hey!
From ribbon bridges to hovercraft and amphibious vehicles, modern militaries depend on innovative mobility systems to overcome rivers, coasts, and other natural barriers. These technologies ensure that heavy equipment, troops, and supplies can keep moving, preserving momentum in combat and safeguarding operational success across any environment. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.